Yes, good evening. This is Vice Rajabi Savidya, and I'm presenting our project titled Flight Ticket Machine Learning Prediction Model. One of the most sophisticated industries that use very complex dynamic pricing strategies for their fares is the airline industry. The airline industry, for it uses a dynamic way of pricing a ticket. Each ticket cannot have the same price, and since it's always dynamic, the price is always changing. And this price, well, what makes the price to change? It depends on the parameters at hand, both external and internal. The internal parameters can be the number of seats on the plane. Then the external parameters can be the holiday breaks or the seasons. These parameters are the ones that judge and they determine the price of the ticket at that time. Now, the flight prices, they're hard to guess. Today's price for a specific journey is different for the same flight tomorrow. Like I said, I talked about the parameters. If today's parameters are different from tomorrow's parameters, the distance and the destination, it doesn't matter, but the parameters are ones that are determining. So the price is going to change. Either the price will increase or the price will reduce. Hence, making a flight price hard to guess. It's not very easy to predict a price of a ticket. Now, the dataset we are going to use for our model, it's found at Kaggle. It's an online platform, and we were able to acquire the Algerian Airlines. Now, part of the related work, we found 3 journals. There's a journal by K. Tidritz. It's an air ticket pricing system, and for him, he used the regression method. In his journal, he talked about the methodology which he used, the feature selection, whereby he was integrating the data model. He separated it in the train set and the train set and the test set, whereby for him, he used a 70% of training data and 30% of testing data. And then another journal is a problem of market segment air level air ticket price system. This one, it's by Tian Wang. For him, he also used a machine learning algorithm, same as Katie treats, and it was the linear. It was the what? It was the random tree regressor. Now, for the flight price prediction, all of them, they used regression models, and even this one, he used the regression model, but for him, he used the decision tree, whereby his model, it was in terms of levels. All of them were using machine learning algorithms, and they were using models, but none of them were using linear regression. For us, we decided to use linear regression since the price that we want to predict, it's a variable, and it's linear. Hence, linear regression being the most suitable model to predict a flight ticket price. Now, the research questions we have at hand: do flight prices vary with airlines? Is the price of Qatar Airways the same as Ethiopian Airways? And how are the prices affected when they are brought in 2 to 3 days before departure? Then does the price change with change in source and destination? If a plane was traveling to, if the plane was traveling to China, the number of stops it gets on the way, do they also participate in determining the price of the ticket? Now, objective, want to develop a flight ticket machine learning prediction model given the different parameters. It's our main objective, and we are going to specifically stand on the linear regression. Since this is a linear regression problem, like I talked about, the price is our target variable and it's dependent. On the specific objectives, how we are going to run our project, we have to get the data. We have to get the data itself, the data set itself. We have to plan and clean it by removing empty cells, removing redundant data. We shall create prediction models. Linear regression will be the one at hand, plus also other regression models whereby we shall have to compare and contrast at the end. We shall train and test our data. For us, we shall use a train set of 80% and a test set of 20%. And then at the end, we shall request the Uganda Airlines to allow us to deploy our model on their website so as to make the prediction. We have already sent a request letter to Uganda Airlines as we await for the acceptance letter. Now, the methodology research design that we had at hand, we shall look at the different websites, getting to know the prices and what is changing the price. We look at them, for example, we looked at Uganda Airlines and we saw why is the price changing from Uganda to from Entebbe to Nairobi. If it was 1.5, why is it changing to 1.7, or why is it changing to 1? Why is there a fluctuation? Why is it decreasing? Why is it increasing? Data collection, we are using a data set from Cargo Platform for an Algerian air industry. And its data set, it's composed of the departure, the arrival, number of stops, the destination, the source. Those are the elements found in our data set. Data cleaning, we shall remove the empty values or empty cells. We shall also minimize on the redundant data of our data set. All this, we are going to be using it in Python. We shall develop our model in Python, whereby we shall use the Python tools to do all this, the cleaning of the data set. Then the model development, we shall also develop our model in Python. Now here we have finished to train, we have finished to do the feature engineering, whereby we have separated our data, whereby there's photo encoding and label encoding. Then we shall test our data, the 30% that I talked about. We shall test it on the 80% of the data. Then the deployment, we have sent a request letter to Uganda Airlines for allowing us to deploy our model on their website. Now, after developing our model, we got these as the results. In front of you on the screen, it's a graph of the Y prediction and the Y test set. And our line of best fit, as you can see, it's a straight line, and we are very happy since we achieved the best results. Now, the summary table, here we use the three models: the linear regression, which is the main point, the random forestry regressor model, and the logistic regressor model. Now, the R score from the linear regression was 1.0, which was the best because the R score is out of 1, and we got 1. The random forest regressor, we got a 0.999, and the logistic, we got a 0.7. And the performance, both the linear regression and the random forest, they got 100%, and the logistic failed. It had a very low performance measurement of 4.6. And now the mean accuracy error of linear regression was 3.7. Its mean square error was 4.5, and the root mean square error is 6. Now, if you look at the summary table, the errors, if you add up the errors of linear regression, they are less than the errors of random forestry, and the logistic having the bigger errors. So making our model being the best among the 3 models. Now, all the above research, we made it, and we found out that linear regression isn't used, and yet the most important variable, the predictor and the response, this is the price, they are continuous, and linear regression is the most suitable in solving this problem. If a person wants to predict an air ticket price, instead of using other models, it has come to understanding that linear regression is the best, and yet it hasn't been used in the journals. And since we used it, we were able to prove that it had the best accurate values. The line of best fit we have seen is a straight line. For others, we were getting it was a scatter diagram. But for the linear regression, the line of best fit was a straight line, and we were very happy about that. The limitations, I talked about sending the acceptance letter, the request letter, but till to date, we haven't been able to get a response from them. We we even failed to get the Uganda Airlines data set. We were in touch with our supervisor. We tried everything. Madame Rose gave me the letter. I sent it there, but we were unable and time was running out. So that's why we referred to the cargo platform and we got an African-based airline since we wanted to make a prediction model based on Africa, not Europe, and we're able to get that one of the Algerian Airlines. Now, the future direction of our research, we want to increase on the performing hyperparameter tuning on the random tree regressor. Now, this random tree regressor, this is what they call hyperparameter tuning. This is when you choose a set of optimal hyperparameters for a learning algorithm. It improves the overall performance of a machine learning algorithm. Since you have to get the values of the n estimators, which are the number of trees in the random forest, the number of features, the max number of levels, the minimum number of samples, the minimum of samples required per split, and the minimum number of samples required at each leaf node. All this can be achieved using the n estimators, max features, maximum depth, the minimum sample split, and the minimum sample leaf. All these are formulas that help in hyperparameter tuning, whereby you get the best results from your random tree regressor. Then we want to train our model on global flight data instead of just concentrating on Algerian Airlines. We want to train our model on the global flights, whereby our model can be able to predict a price ticket in Europe or in Uganda or in Kenya, everywhere. When a person uses our model, he or she can be able to predict that. We want to explore furthermore on the feature selection part, minimizing overfitting leading to generalization, because when we are feature engineering, we tend to maximize on the overfitting. So right now we want to minimize on the overfitting and we want to generalize everything instead of specializing it. And these are part of the examples of the references whereby we used to conduct our research. And lastly, we want to thank our supervisor, Mr. Lule, who has always been there for us. He has acted as a parent. He has guided us. He has corrected our mistakes. He has always been responding to us. And last but not least, Dr. Rose, who's the project coordinator, who has had our views, understood them, been in touch with her, and she has helped me a lot throughout my project. That's all I had for today, introducing our project. Thank you.